In this video, we will be learning part 11.3 volume of a right circular cone in chapter 11 surface areas and volumes of class 9 CBSE. We will also be solving exercise 11.3 questions. Let's take a look at the formula for volume of a cone. The formula for volume of a cone is obtained from the formula for volume of a cylinder by comparing the cylinder and the cone. Here we can see that there are two figures, one of the cylinder and other of the cone. Both have the same base radius r and same height as h. Now, volume of a cylinder can be obtained by multiplying the area of the base of the cylinder with the height of the cylinder. Volume of a cone, however, of a right circular cone has been observed to be equal to 1/3 the volume of a cylinder. Here you can assume that with the same radius and the same height, if this cone were to be placed in the cylinder, it would occupy 1/3 of the volume. That's why we say volume of the cone equals to 1/3 the volume of the cylinder. Now let's find the volume of the cylinder. So I know that the area of the base is pi r square because base is a circle, and multiplying it with height, I get volume of the cylinder as pi r square h. Now, writing volume of the cone as 1/3 of volume of the cylinder, I can say volume of the cone is 1/3 pi r square h. Now, let us solve some exercise 11.3 questions that are based on this formula for volume of the cone. We are asked to take the value of pi as 22/7 unless it is mentioned otherwise. First question is, find the volume of the right circular cone with radius 6 and height 7 centimeters. I know that the formula is 1/3 pi r square h. Now substituting radius and height values, I can write 1/3 into 22/7 into 6 into 6 into 7. So here 7 and 7 gets cancelled and I can say 3 ones, 3 twos are 6. So I am left with 22 into 2 into 6, which is 264 centimeter cube, that is the volume of the cone. Second part in the first question, radius is 3.5 centimeters and height is 12 centimeters. Volume of the cone formula is 1/3 pi r square. Now substituting the value of radius and height, I can write as 22/7 into 3.5 into 3.5 into 12 into 1/3. Here I can simplify. 3.5 ones are 3.5 twos, 3 ones are 3 fours are, and 2 ones are 2 11s are. Now I am left with 11 into 4 into 3.5, which is 154 centimeter cube. Next question says, find the capacity of a conical vessel in liters where radius is 7 centimeters and slant height is 25 centimeters. Here we have to find the volume of the conical vessel in order to find its capacity. We are given r as 7 and L, which is the slant height, as 25 centimeters. Now I need to find the value of h, for which I am going to use L square equals to r square plus h square, where I know that h square can be written as L square minus r square. So h can be written as square root of L square minus r square. Substituting the values in order to find h, I get 25 square minus 7 square, which is square root 576, and the value for h will be 24 centimeters. Now I can substitute this value of h in the formula for volume, which gives me 1/3 into 22/7 into 7 into 7 into 24. Here 7 and 7 gets cancelled and 3 ones are 3 8s are. So I am left with 22 into 7 into 8, which is 1232 centimeter cube. Here I know that 1 centimeter cube equals to 1/1000 liters. 1232 centimeter cube will be 1232 divided by 1000 liters, which will be 1.232 liters. In second part of question number 2, height is given as 12 centimeters and slant height is 13 centimeters. In order to find the capacity of the conical vessel, we have to find the volume again, and here I need the value of radius in order to find the volume. Using L square equals to r square plus h square, I get r square equals to L square minus h square. So I can write r as square root of L square minus h square. Substituting the value of L and h, I get 169 minus 144, which gives me r as square root 25, which is 5 centimeters. Now I can use the value of h and r in order to find the volume. The formula for volume is 1/3 pi r square h, and substituting the values, I can write as 1/3 into 22/7 into 5 into 5 into 12. So 3 ones are 3 fours are, Now I'm left with 22, 5 into 5 is 25 into 4 by 7, which is 22 into 100 by 7, which is 2200 by 7. So volume of the cone is 314.28 centimeter cube. Now converting this into liters, I can write as 314.28 by 1000, which is 0.31428 liters. Third question says the height of a cone is 15 centimeters. If its volume is 1570 centimeter cube, find the radius of the base. Here we are asked to take the value of pi as 3.14. Now I know that 1 by 3 pi r square h is the formula for volume. Equating it to the given value over here, to find r, I can substitute h as 15 centimeters that is given to me, and I can write it as 1 by 3 pi is 3.14 into r square into h is 15 should be equal to 1570. Here 3 ones are 3 5s are. Making r the subject and sending 3.14 and 5 to the other side, I can write r square equals to 1570 by 3.14 into 5. Here r square value will be 314 by 3.14. Now I can write 3.14 as 314 by 100. So I'll be left with 314 by 314 into 100. 314 ones are 314 ones are. R square value is 100, from which I can write r as square root of 100, which gives me the value for r as 10 centimeters. In the fourth question, we are given the volume of a right circular cone of height 9 centimeters as 48 pi centimeter cube. We are expected to find the diameter of its base. To find the diameter, I need to find the radius first. So writing the volume as 1 by 3 pi r square h and equating it to the given 48 pi, and then finding r from this gives me 1 by 3 pi r square, height is 9, equals to 48. Here I can say 3 ones are 3 threes are, and pi gets cancelled. So I can write 3r square as 48. Here 3 ones are 3 16s are. So r square is 16. That gives me r value as square root of 16, which is 4 centimeters. Now finding the diameter, I need to multiply r with 2. So 2 into 4 gives me 8 centimeters as the diameter of the base of the cone. Fifth question says a conical pit of top diameter 3.5 meters is 12 meters deep. What is its capacity in kiloliters? Putting the information in a figure, it gives me a conical pit shape here, and here the whole diameter is 3.5 meters and the height is 12 meters. Now finding the radius from the given diameter gives me d by 2 equals to 3.5 by 2 meters, which is 1.75 meters. I need to find the volume in order to find the capacity. So substituting r and h values in 1 by 3 pi r square h gives me 1 by 3 into 22 by 7 into 1.75 into 1.75 into 12. So I can say 3 ones are 3 fours are. I can write this as 22 into 1.75 into 1.75 into 4 by 7, which can be further simplified to 269.5 by 7, which is 38.5 meter cube. This is the volume of the conical pit. Now in order to find the capacity in kiloliters, I need to convert this meter cube to kiloliters. I know that 1 meter cube is equal to 1 kiloliter. 38.5 meter cube will be equal to 38.5 kiloliters. In the sixth question, I am given the volume of a right circular cone as 9856 centimeter cube. If the diameter is 28 centimeters, find the height of the cone. I am given volume and diameter of the base. We need to find the height. So d is 28 centimeters. From this I can find the r value as 14 centimeters. Now I know that 1 by 3 pi r square h equals to 9856 centimeter cube. Substituting the value for r here, I can write as 1 by 3 into 22 by 7 into 14 into 14 into h equals to 9856. 7 ones are 7 twos are. So this becomes 22 into 2 into 14 by 3 into h will be 9856. Making h the subject gives me 9856, 3 goes to that side and goes to the numerator, and the rest of it comes to the denominator. Here 14 ones are 14 into 704. So I am left with 704 into 3 by 22 into 2. Again 22 ones are 22 threes are 22 twos are. So that becomes 32 into 3 by 2. This can be further simplified by 2 ones are 2 16s are. So this can be written as 16 into 3, which is 48 centimeters. The second part of the question asks us to find slant height of the cone. Now that we have found the value of h as 48 centimeters and r is given to us as 14 centimeters, we can substitute in this formula to find slant height or L. Upon substitution, 14 square plus 48 square becomes 196 plus 2304, which is equal to 2500. So square root of 2500 is nothing but 50 centimeters, which is the slant height. Third part asks us to find the curved surface area of the cone. The formula for curved surface area of the cone is pi into r into L. So 22 by 7 into 14 into 50 gives me 7 ones are 7 twos are. So 22 into 2 into 50, which is 22 into 100, which is nothing but 2200 centimeter square, which is the curved surface area of the cone. In 7th question, we are given that a right angle triangle ABC with sides 5 centimeters, 12 centimeters and 13 centimeters is revolved about the side 12 centimeters. Find the volume of the solid obtained by the revolution. Now take a look at the figure to understand this. We have said that a right angle triangle is revolved about the side 12 centimeters. So the height is taken as 12 centimeters and the radius is taken as 5 centimeters and the hypotenuse or the slant height is 13. Now upon revolution we obtain a cone with the given dimensions. Now in order to find the volume of the solid, I need to find the volume of the cone, which is 1 by 3 pi r square h. Substituting r and h values gives me 1 by 3 into 22 by 7 into 5 into 5 into 12. So 3 ones are 3 fours are. This I can write as 22, 5 into 5 is 25 into 4 by 7, which I can write as 22 into 100 by 7. So 22 by 7 is pi. So I can write this as 100 pi or 100 into 3.14 as well, which will give me 314.28 centimeter cube. 8th question says, if the triangle ABC in question 7 is revolved about the side 5 centimeters, so here we are supposed to take the height as 5 centimeters, then find the volume of the solid so obtained and find the ratios of the volume from question 7 and question 8. The right angle triangle that is supposed to be revolved about 5 centimeters looks like this. Now this 5 becomes height and 12 becomes r. And slant height remains the same, which is 13. Now we can use these values to find volume, the second volume for question 8 and take the ratio with the first volume. So in question 7, we got the volume as 100 pi centimeter cube. Let that be V1. In question 8, we have R as 12 centimeters and H as 5 centimeters. Substituting that in order to find V2, that is the second volume, I have 1 by 3 into pi into 12 into 12 into 5. Here I have not taken the value of pi as 22 by 7 because when I am doing the ratio, it is easy to cancel. So here 3 ones are 3 fours are. I am left with 4 into 12 into 5 into pi, which is 240 pi centimeter cube. This is the new volume if the cone were obtained by revolving about the 5 centimeter side. Now to find the ratio, I can do V1 by V2, which is 100 pi by 240 pi. Pi gets cancelled. I can cancel the zeros and write as 10 by 24. So 2 5s are 10 and 2 12s are 24 gives me 5 by 12. So the ratio of the 7th question and the 8th question can be written as V1 is to V2 equals to 5 is to 12. In the 9th question, we are given a heap of wheat is in the form of a cone whose diameter is 10.5 meters and height is 3 meters. Find its volume. The heap is to be covered by a canvas, so find the area of that canvas as well. Here I know that I need to find the volume of the cone and also curved surface area in order to find the area of the canvas that is needed to cover the cone. Starting with diameter that is given to us as 10.5 meters, finding the radius, I get r value as 5.25 meters. H value is given to me as 3 meters. Substituting that in the formula for volume, I can write as 1 by 3 into 22 by 7 into 5.25 into 5.25 into 3. Now 3 and 3 gets cancelled. I am left with 22 into 5.25 into 5.25 is 27.5625 by 7. This will give me the value as 86.625 meter cube. Now finding the curved surface area pi RL. Now in order to find pi RL, I need to find the value of L first. I have the value of R, I have the value of H. I can substitute it in this formula and find the value for L. So I get L as 5.25 whole square plus 3 square, which is 27.5625 plus 9, which is nothing but square root 36.5625. I get this value as 6.047. Here, if you want to know how to find the value of such complicated square roots without using a calculator, check out the link given in the description below, where I have provided a simple procedure in order to simplify and calculate such complicated square roots. Moving on, substituting this value of L in curved surface area formula, which is pi into R into L, 22 into 7 into 5.25 into 6.047 gives me 698.429 by 7, which is 99.78 meters square. That is the area of the canvas that is required in order to cover the heap or the cone.